you have not stopped. You're always publishing research. And I wanted to start by talking about the latest publication that you came out with just a few months ago. I don't have it right in front of me. I was just reviewing it not too long ago. Can you tell us about the study that you just researched and were able to get published?
Right. I will tell you, this is, I think, is one of the most important papers uh, that we published. It was me and my partner, Professor Anbar Kai from Tel Aviv University. And for that, I need to give you a little background in evolutionary theory. Okay, so Darwin presented this theory, and the theory very simply say that there are some pressures, environmental pressures, and animals or plants get adapted to this pressure. So they have to change something, and that something changes. Either there was already diversity in the species itself, so they select the individuals that fit best the new situation, or we wait until there are some changes in the gene, mutations, and these individuals survive. And that was nice and dandy until quite a while ago, but not many years ago. Some people came and said, well, it doesn't really describe the reality of nature in full. Because, and the external pressure that Darwin was talking about, and most scientists still today think is the main cause of evolution, is, for instance, climate. Okay, or volcanism, or some powerful, powers of nature, yeah, that like climate. But other scientists came and said, look, this is just described very small part of the causes of evolution, because there are a lot of pressures that happened inside the niche. So each animal lived in a physical niche, let's say in a place, okay? And they live with other animals. They affect other animals. Whatever other animals do affect them, affect the plants in their area, etc., etc. So you have in a niche a whole community of living creatures, okay, including trees, plants, animals, that affect each other. And we have to take that into account too. So it was called niche construction theory. And the thing about niche construction theory, the big difference, is that the pressure doesn't come from such large powers that we or the animal that got affected has no reciprocal pressure. So, but in small niches, let's say, if you have something happen to one animal, that can affect other animals. The fact that these animals is now less prevalent in the environment may affect other animals. That can affect the initial change. So the change can affect change. So it's reciprocal. And this leads to some type of directionality, because you have processes that sort of feed themselves. Okay, if you have a change in the weather or the climate, and it's a pressure, but whatever the animal do, it won't change the climate. But if you talk about a niche, whatever happened to the animal changes the niche. So there are reciprocal processes, and these processes tend to be to lead to some directionality. Now, when you go to human evolution, there is very strange phenomena, and this is the directionality, for instance, of brain growth. So brain grew from about 2.6 million years until about 2.3 million years. Okay, for 2.3 million years, brain grew continuously. Now, if it was just a result of external pressure, like climate, it doesn't make sense because the climate, is fluctuating. Yeah, so it should actually lead, whatever climate, let's say the drying up led to the extension of the brain or the growth of the brain because the landscape became more savanna-like, etc., etc. Okay, so that happens once. Now, why it continued to grow? The climate didn't become even drier and drier and drier for the last 2.3 million years. It becomes, sometimes it was wetter, sometimes it was drier. So there is no directionality in what is called the selecting agent. In other words, the pressure source, okay, the driver. There is no directionality in the climate, so why would there be directionality in the result? In other words, Darwin's classical theory doesn't explain the directionality of human evolution. It's not only the brain size, it's many things. For instance, the shape of stone tools. The size of stone tools went down. Fire became used, there was the use of fire became more and more intensive. The cultures became shorter and shorter. In archaeology, we call the culture, whatever, like a set of tools has a certain shape. And then you see that there's a new set of tools. So you call that a different culture. So the first culture was 1 million years old, and the second culture was 1 million years old, and it was worldwide. Third culture was already 300,000 years old, or lasted for 250, 300,000 years. And the next cultures always lasted for tens of thousands of years and became very fragmented spatially. In other words, in many places, different cultures. So the tendency of cultures to get shorter and fragmented. A lot of changes is like that. They're changing in a direction, and that Darwin's theory cannot explain. So I said, okay, maybe the niche construction explain with our theory. The niche construction can explain what happened, and I found out that's what happened actually, because what we said initially, since man the fat hunter, is that humans, because of the constraint on the consumption of protein, had to consume either carbohydrates or fat to the tune of about 65% of the calories. Now, and we supported with future research, in later research, we supported the fact that we were carnivores, so really it paid us, energetically speaking, to complete it from fat rather than carbohydrates. Well, that necessity to complete it from fat caused us to do three typical or three patterns of behavior. One is to hunt large animals, because large animals have, relatively speaking, more fat, and they maintain more fat during dry periods because they can consume low quality forage and they don't need to exploit their fat so much. Also, they don't run away, so they can carry more weight. They don't have to be efficient in running. So these are large animals. The second segment that humans used to exploit are the prime adults. In other words, in a herd, you have the old, you have the young, and you have the middle section, which is the prime adult. And humans have tended to hunt the prime adults, which is crazy from a predator's point of view, because the prime adults are the most experienced and are in the best physical shape. So it's crazy from a predator just to actually pick them up, unless you find out that they have more fat. Because their teeth are mostly gone, and they don't eat that much, and the young need the fat to grow, so they don't accumulate that much fat. So this is the second pattern. The third pattern is that humans used to take bones, or to take the parts that were fatter and leave parts that had no fat and did not consume them. So it's like wasteful hunting. So you hunt and actually use only 50% of the, compared to other predators, and when they hunt, they use all the animals. Anyway, these three patterns actually reduce the robustness of the population, because large animals take many years to replenish the population because they take many years to grow. Like elephants, for instance, they become sexually mature at something like 16 years or 17 years old.
Oh.
And deer becomes sexually mature after 1 year or 2 years. So they can renew the population. If they have some pressure, they can renew the population quite quickly, but elephants can't. So they are more sensitive to predation, to high level of predation than deer. So that's the first thing. The second is that the prime adults are the population that actually responsible for the new generation, for creating the new generation. And the third is that we just hunt too many. We just hunt more than we need. But we hunt because we need the fat. We don't need the meat so much. So we hunt more than other predators. So these three things create a pressure on these populations. And what happened is that in the next generation, etc., you find smaller and smaller animals. You find that the large animals get extinct. Now, they may get extinct not just because of the human pressure. Maybe there was also climate stress. But the climate stress was more effective because of the human pressure. So this is how the niche construction comes into play, because humans, because of their protein constraint, consume certain segment of the population of the herbivores in the niche. There's a smaller number of herbivores. Then humans go and hunt the smaller number. Okay, and so you have a process that actually show you continuity of pressure. And this explains the continuity in the phenomenon that you see, like brain growth. Because in our case, they have to adjust to hunt smaller animals that run faster. They're a smaller target. So this is how we were able to show in the paper that humans were the driver of the decline in prey size, and the decline in prey size was the driver of brain growth, because we needed to learn how to cope, and we really couldn't run faster ourselves. So we had to develop, for instance, bow and arrow, and that the arrow can run faster after the animal instead of us. So, so it explains, it puts all the theory that we had already published in the past, but now were able to put it in the context of a modern evolutionary theory and explain why, and this is almost a consensus, is that humans were the ones that caused the decline or the extinction of large animals. Some people still object to that, but most researchers, I think so. You know, there's no committee that decides what is a consensus or not. So, but it looks to me that nowadays most researchers accept that humans were the ones that caused the extinction. For instance, for the main reason is that whenever they appear, wherever they appeared, large animals disappeared. So, for instance, in America, in Australia, in islands like New Zealand, where humans appear a bit later than usual, than in Europe, for instance, or in Africa. And quite a few years after a few years, you know, it could be thousands of years, but few in terms of, you know, geological terms, large animals started to disappear. So that starts to explain why, because these people that support the human contribution to extinction don't explain why it was. They just say, oh, humans were smart. Well, if they were smart, they would leave the animals, you know, the large animals, enough of them for the next meal. But they could not, because they had to have the fat. So this is how we explained, and this is the last paper that we wrote. So really, it's like, for me, it closes the whole explanation from the beginning, the fat, to now to have a full picture.